Hi, I'm Shuichi Murakami. Welcome back to the Basics of Landscape Form series. Last time, we learned how to represent landscapes using axonometric drawings. That method gave us a bird's-eye way of showing how different elements in three-dimensional space are related to each other. This time, let's explore perspective drawing, a way to represent how things actually appear to us. Perspective is about expressing how you perceive the arrangement of its elements. Let's imagine two rows of three columns as shown in the plan above. When expressed this scene in perspective, it looks like the figure below. The columns are all the same size and evenly spaced, yet the closer ones appear larger, the further ones smaller. This matches our actual visual experience. That's what perspective drawing is, a method to depict the visible form of a three-dimensional space on a two-dimensional surface. The drawing process is not as simple as axonometric, but nowadays with CAD and AI tools, we can generate perspectives automatically. So, perhaps we don't always need to learn the drawing methods in detail. However, understanding the principles of perspective lets you predict how changes in space will affect what we see. And once you can predict that, you can truly design space. When drawing a perspective or looking at one, it is important to keep the basic elements clearly in mind. Viewpoint. Its position is determined by horizontal and vertical distance from the object and by orientation. Sight line. The straight line representing the view direction from the viewpoint. In this case, the viewpoint is set on the center line of the corridor. In perspective drawing, it is also crucial to be conscious of the eye level and the ground level. In this case, both the ground and the eye level are horizontal. Now comes the main player, the vanishing point. The vanishing point is where objects moving away from you appear to meet. Of course, nothing truly disappears, but assuming they do is the key to perspective. For example, all lines parallel to the sight line resolves to a single vanishing point. In this case, both the left and right rows of columns are parallel to the sight lines, so they resolve to the same vanishing point. But what if the columns are not parallel to the sight line? If the left row rotates, its vanishing point moves to the right on the horizon. If the right row rotates, its vanishing point moves to the left. Thus, each line's direction determines its vanishing point. In this case, shown in black, red, and blue, we have three. Now that you know the basic elements, you may wonder how can we find the precise location of vanishing points and draw a perspective accurately. Here is the outline. Prepare a perspective drawing plane and place the plan view above it. Mark the viewpoint and sight line on the plan, aligned so that the sight line passes through the center of the perspective. Draw the projection line on the plan and draw the horizontal lines of the eye level and ground level on the perspective. Add the elevation view of 3 columns on the ground level in the same scale as the plan. To find vanishing points, extend the line parallel to the column's direction from the viewpoint until it intersects the projection line. Then drop the vertical to the perspective plane. The intersection with the eye level line gives the vanishing point. Extending the column line to the projection line. Then from the intersection, drop the vertical down to the ground line of the perspective plane and mark the column height as in the elevation. By connecting the vanishing point to the top and bottom ends of the column height in the elevation, and extend these connections so that they become the perspective lines of the columns. Project the position of each column from the viewpoint onto the projection line. Then drop the vertical down to the perspective line to set the column's position and height. In this way, the perspective of 3 columns can be drawn. How do we plot a precise point in 3-dimensional space onto a perspective? The principle is the same. Draw the side line and the horizontal lines of the eye level and the ground level. Assume the point lies on a line parallel to the side line. The vanishing point of the line is the intersection of the side line and the eye level line. Project the point height as an elevation at the same scale as the plan. Connect the point height to the vanishing point to form the perspective line. Project the position of the point from the viewpoint onto the projection line. Drop a vertical to this perspective line, and this is the precise point in 3-dimensional space. By repeating this, any point in 3D space can be placed accurately in the perspective. By applying this projection method of perspective, more complex landscape forms can be drawn accurately. Here is a perspective drawing of a winding garden path. By plotting the exact location of key points along the path and connecting them, the curved lines of the path can be represented in perspective. Here is a perspective of a small hill, about 2 meters high. For landscape forms, the plan is usually expressed with contour lines. From the viewpoint, the form of the hill is defined by the ridgeline and front line of the front slope. By tracing the ridgeline from the contour lines, projecting its key points, and connecting them, the shape of the ridge can be drawn. Likewise, by projecting the key points along the lowest contour line on the viewpoint side and connecting them, the foot line of the front slope can be represented. Today, we learned the basic elements and the methods of perspective drawing. With concepts like viewpoint, vanishing point, sideline, the horizontal lines of eye level and ground level, you will see and draw perspective differently. Through practice, you will also understand how changing the viewpoint or object positions alter what the space looks like. knowledge that empowers true spatial design. That concludes today's lecture. Through this Basics of Landscape Form series, we have learned how to see, draw, and understand space in various ways. This is the end of the series for now, but additional episodes may be added in the future as needed. Please stay tuned. Next time, we will begin a new series, Designing Landscape Form. The first episode is Let's Design Visually Dynamic Landscape Forms. We will shift our focus from grasping form to creating form and explore landscape even more deeply. See you in the next episode.